This video will cover the Geometry Regents exam from June 2015, questions 35 through 37. Number 35 says, solve the following system of equations graphically. State the coordinates of all points in the solution. So the first step is to get each equation into y equals. So I have y plus 4x equals x squared plus 5. So what we're going to do is subtract 4x, so we have y equals x squared minus 4x plus 5. And you're going to type this equation into the calculator. From there, you'll get some coordinates, some points, and you'll be able to plot them. If you need to make a table so that it's easier for yourself, then say go from -3 all the way up to +3. Write those coordinates down here and then plot them. You're also going to need to get the second equation into y equals. X plus y equals 5. Subtract x, so now we have y equals -x plus 5. This one's nice and easy to plot because it's linear. You could still, again, type it into your calculator, but I'm going to do this one by hand. I'm going to use the calculator for the other one. So we have y equals -x plus 5, which means our y-intercept is +5. And then we're going down 1 over 1 because it's a -1x. I'm just going to plot it until I can't plot anymore. And then I'm going to connect, cap it with arrows, and write the original equation, x plus y equals 5. So now I'm going to take a second to type the equation into my calculator for the red equation there, the x squared minus 4x plus 5. And so I'm going to go to graph on my calculator. I'm going to delete everything that's in there. Let's see. And I'm going to type it in. I have x squared. I know you can't see my calculator, but you should do the same thing. X squared minus 4x plus 5. And then I'm going to look at the table. If you have a TI Inspire, the quick way to get to the table is Control T. Control T. So again, we said that we're going to go from -3 to +3. -3 outputs a value of 26. -2 outputs 17. -1 outputs 10. 0 outputs 5. 1 outputs 2. 2 outputs 1. 3 outputs 2. I'm going to keep going with 4 and say 5. 4 outputs 5 and 5 outputs 10. This is just so that I can get everything plotted as possible on my graph. So obviously I'm not going to graph the first 2 coordinates, but I can graph -1, +10. So that's here. Then 0, 5, 1, 2, 3, 4, 5, that's here. Whenever I get a double dot, meaning they intersect, I'm going to put a circle around it so I don't lose it. Over 1 up 2, over 2 up 1, over 3 up 2, double dot, circle, over 4 up 1, 2, 3, 4, 5, over 5 up 10. So we have this nice symmetric quadratic equation being plotted here, and I'm writing the original y plus 4x equals x squared plus 5. Now it does say to state the coordinates of all points that satisfy the solution or are in the solution. So we need to state the coordinates. We had 0, 5 and 3, 2. Number 36 says, in parallelogram ABCD with diagonal AC drawn, and then they give us a bunch of the other information. So I'm going to sketch this real quick. A, B, C, D with diagonal AC drawn. The measure of angle BCA, B to C to A, is 4x plus 2. And the measure of angle DAC, D to A to C, is 6x minus 6. Measure of angle BAC is 5y minus 1, and the measure of angle DCA is 7y minus 15. And our goal is to find the measure of angle B, so let's call that, I don't know, just B. So before we find B, we actually have to find x and y first. So if you think about properties of a parallelogram, we know that the opposite sides are parallel, which actually helps us find the letter Z. And in the letter Z, we have congruent angles. We're going to say congruent alternate interior angles. So I can set these two expressions in green equal to each other. 4x plus 2 equals 6x minus 6. I can also do the same because if I look using the other pair of parallel lines, we have a z going this way, giving me these two angles that are congruent. So now we have 5y minus 1 equals 7y minus 15. Take a couple minutes to solve those, and while you're doing so, pause the video and then come back and check in with me to see what x and y should be. So I found x to be 4 and y to be 7. So then we have to find the measure of angle B. And if you look at our picture, we have this triangle with one of the green angles, one of the blue angles, and then B, which is of course what we're trying to find. If you focus on a triangle, then that actually helps us because 3 angles in a triangle sum to 180. So we have 4x plus 2 plus 5y minus 1 plus b equals 180. Now we know y is 7 and we know x is 4, so we're going to plug both of those values in at the same time. 4 times 4 plus 2 plus 5 times 7 minus 1 plus b equals 180. 4 times 4 is 16 plus 2 more is 18. 5 times 7 is 35 minus 1 more is 34 plus b equals 180. 18 plus 34 gives us 52 plus b equals 180. So then b equals 128, which means because we called angle B, the measure of angle B is equal to 128 degrees. Number 37 says point P is 5 units from line J, so I'm just going to indicate that by drawing a line 5 units. Sketch the locus of points that are 3 units from line J. So I'm going to start by sketching 3 units from line J. So you can think about this, if you have a line and you want to be 3 units from it, you could go up 1, 2, 3, right here. You could also go up over here, 1, 2, 3, right here. Over here, 1, 2, 3. 1, 2, 3. 1, 2, 3. And you can see that this line, this dotted line, is being formed. Not only can we go above, but we could also go below 3 units. 3 units, 3 units. So I'm going to sketch that, understanding that P is still 5 units away. So I need to go just above halfway. This is 3 units. This is 3 units. Locus is always dotted. And locus just represents the points that are a given distance away from a line, a point, a set of points, whatever it happens to be. We also need to go 8 units from point P. So remember that this is 5, this is 3, so this is one spot that's 8 units away. But not only can I go down 8 units, I could go over here 8 units, over here 8 units, here, 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 here. And you can see that going 8 units away in every single direction ends up resulting in a circular form. So 8 units over here, we'll go out 8 units, up 8 units, to the left 8 units, to give us this dotted circle. Now our goal here is to label with an X all points that satisfy both conditions, meaning dotted meets dotted. So I'm looking for where my blue dotted meets my purple dotted. That definitely happens down here. It happens over here on the right and over here on the left. That's all you need to show for this problem.